Hi friends, welcome to GMK tutorials. In this video, we are going to see about the mass combination circuits in low power VLSI concepts. So let us see first one. So generally mass combination circuits means that obviously it can be designed with the help of a metal oxide semiconductor field effect transistors, right? So let us see first one is nothing but there are two basic approaches for realizing the digital circuits, that is nothing but one is nothing but switch based circuits and second one is nothing but gate based circuit. So switch based circuit is nothing but a switch logic is based on the pass transistor. It can be used with the help of a pass transistor, or else we can also use a transmission gates. It is just like a relay circuit. Like a relay is nothing but which passes the either low high voltage in the absence of input voltage, that can be treated as the output is can be as a low value. But if any small voltage is also present in across the input terminals of the corresponding relay circuit, obviously which produces a high output, right? So that is a case. So let us see on the other hand, the gate logic is based on the realization of the digital circuit using inverters and other conventional gates. It's like a TTL, transistor to transistor logic families. So let us move on to the next one. Moreover, depending on the how circuits function, they also can be categorized into two types. That means depending upon the function of the circuits, it can be classified into two categories. One is static circuit and second one is a dynamic circuit. In case of a static circuits, no clock is necessary for their operation and the output remains as long as the supply voltage is maintained in the static circuits. So in case of the static circuits means the output of the static circuit is always high up to the input up to the supply voltage is maintained. In case the supply voltage is not present to the corresponding static circuit, at that time the output should be zero or output goes to the low value. Coming to the second one, dynamic circuits is realized making the use of the information storage capability of the intrinsic capacitors present in the mass circuits. Like if you are seeing in case of the metal oxide semiconductor, in the output side we are connected the one load terminal, right? So if it is a metal oxide semiconductor, let it be considered as a NMOS transistor. At that time, gate, source, drain. So across this one capacitor, so this capacitor stores the corresponding voltage, whatever it is supplied from the corresponding power supply. So let us go for the next one. So this is a pass transistor output driving another pass transistor cell. So it is nothing but a NMOS. So one important point is noted here is pass transistor logic families can be designed with the help of a NMOS circuits here, right? So this is nothing but output of the first pass transistor. This output of the first transistor can be used as a input for the second transistor. So that's why the output of the pass transistor is used as a driving for the another pass transistor. So let it be see here, one important point is nothing but generally this is a pass transistor, right? So in case gate terminal as well as drain terminal both are in the high range, at that time the source voltage VDD minus VT only, because of if the source voltage crosses this voltage, obviously the corresponding NMOS transistor is going to be in half condition. Why? Because of generally we know that when the gate to source voltage because of let us see because of when the gate to source voltage, so generally this mass transistor is activated only whenever this VGS voltage is greater than VT. At that time only the corresponding NMOS transistor is going to be in on condition. Suppose if you are treating this one, it is in the fashion of like this. right? This is the gate terminal, this is the source terminal. This gate voltage must be greater than source voltage. But here the problem is that this gate and drain, these two both are in a high value. Therefore, at that time, it is whenever this source voltage is low, at that time only the corresponding MOS transistor is going to be on condition. So for that purpose, obviously this NMOS transistor requires 1 volt or VT is a threshold voltage required for the NMOS transistor is an on condition. That means total gate voltage minus threshold voltage of the corresponding transistor remaining whatever the voltage is, that voltage the source voltage cannot exceed that voltage. If the source voltage exceed that voltage, obviously gate voltage is less than the source voltage. At that time the corresponding NMOS transistor is going to be in half condition. So for that purpose, in this consideration the output of the pass transistor is only output of the pass transistor is only VDD minus VT. So that voltage can be supplied as an input for the second transistor, right? So let us see the next one. So this is a realization of the logic family with the help of a, it can be realized with the help of a so let us see the next diagram. So in this case, this circuit is realized with the help of a relay logic actually. So let us see this function is nothing but here f is equal to a plus b bar c. So this is a value. So here this is nothing but a b bar c, nothing but, right? So one important point you have to notice here, b bar c is nothing but is a product operation, right? So that product can be realized with the help of a series fashion of the corresponding. So B bar and C bar circuits can be connected in series fashion, and A, this total product B bar C as well as A both are in the addition format, like adder format. So that can be realized with the help of a series fashion. That is the one important point you have to notice, that if you are realizing the any kind of the circuit with the help of a transmission gates, or it may be pass transistor or whatever it may be, right? So let us next see in the second consideration. The second one is in the pass transistor logic family. With the help of a NMOS transistor, we can design the circuits in this fashion. So third one is nothing but, so this is a pass transistor. Second one is a pass transistor network corresponding to the relay logic. As well as this is a proper designing for the third one. C is a proper designing for the pass transistor network for the corresponding. That means you have to provide a one discharging path compulsory to the corresponding circuit. Otherwise, it leads to the same value for the next value also. So next one. So this is a realization of a pass transistor logic. So pass transistor can be used to realize a multiplexers of a different types, like 2x1 multiplexer and 4x1 mux realization can be done with the help of a pass transistor logic family. Moreover, two variable functions also can be realized with the help of a MOS transistor family. So this is a two variable function can be expressed. So this is nothing but a one function can be taken, f of a comma b, z naught into a bar b bar. So this can be accomplished with the help of a Shannon-Fano theorem. So this Shannon-Fano theorem states that, like, if f of x is a function, it is an independent variable. At the time, it can be represented as f of xi into x plus x bar into f of xi. So this is a format. It can be represented in the form of a complemented format. It can be represented like this, right? So this is a two variable function actually. So this is a multiplexer circuit for 2x1. This is a 2 by, first one is nothing but a 2x1 multiplexer. This is nothing but 4x1 multiplexer. So with the help of a pass transistor logic, we can design it 2 by 1 as well as a 4 by. So two inputs G1, G1, G0 are the two inputs, as well as V0 is the output. Suppose A is equal 0, at the time the second transistor is going to be on, therefore G0 will be appear across the V0 value. Suppose A is equal to 1, at the time the first transistor is going to be in activation condition. So this is going to be activated at the time V0 is equal to G1. Suppose A is equal to 0, at the time this corresponding transistor is going to be in on condition. So depending on, so A is equal to 0 means that actually you have to notice one more important point is here. So these two are the NMOS transistor. That means obviously for 0 voltage these two NMOS transistor cannot be is in on condition. So for that purpose we are taking the complementer for, right? Suppose if A is equal to 0, what happened? First transistor, this transistor is going to be is in half condition, right? So as well as second thing is nothing but if A is equal to 0, A bar value is equal to 1, right? So this is connected to A bar, right? This transistor is going to be non-condition, right? At that time G0 will be present in this one. So when A is equal to 1, the first transistor is on, second transistor is going to be half condition. This is a scenario how the MOS transistor is going to be operated for. MOS transistor as well as pass transistor can be used as a 2 by 1 multiplexer as well as a 4 by 1 multiplexer designing. So let us see the next one. So these are the advantages of the pass transistor family. The first one is nothing but ratioless. Ratioless means in case if you want to design any inverter, suppose if you have any idea in the pass transistor passive resistor used as a pull-up network, at that time the compulsory condition is nothing but load resistance. At that time load resistance must be greater than channel resistance of the pull down network. That means whenever this satisfies this condition, at that time only the corresponding NMOS transistor is an act as an inverter. So this is one of the very important consideration if you are maintaining a pull-up network is a passive network or it may be a PMOS transistor. The condition should be load resistance, that is nothing but a passive resistor pull-up network resistance must be greater than 4 times that of the channel resistance or as a pull down network. So in this consideration it is a very advantage is that because of here because of in this consideration ratioless means that the pass transistor can be minimum dimension. Moreover, the pass transistor cannot use any kind of the VDD supply, cannot be used any kind of the passive network. Passive resistor is a pull up as well as a PMOS resistor. So that's why we don't have to maintain any ratio that is nothing but W by ratio of the corresponding pull up as well as pull down network. That's why we don't have any such a type of a ratio problem. So that's why it is a ratio. Second one is nothing but powerless. So in case of the pass transistor circuit, there is no static as well as a direct connection. That means in case of the PMOS and a pass transistor, we don't have any kind of the PMOS circuit will be present in the pull-up network. So that's why you don't have any such a kind of the short circuit as well as a switching power dissipation takes place in the corresponding. So, like static power dissipation and short circuit power dissipation, such a type of problems are not present in case of the pass transistor. As well as the lower area compared to the like the CMOS network. In case of the CMOS network, we have a one pull-up network as well as a pull-down network. That's why it needed two gates for the realization of the one inverter. But if you go for the pass transistor logic family, only with the help of a single gate, we can realize the corresponding pass transistor family. That's why it takes a very lower area. So this results in a small number of a transistor and a smaller number of input loads. This in turn leads to a small chip area and a lower delay and a small power consumption. These are the advantages of the pass transistor if you are using the right. So coming to the next one, these are the advantages of the, what are the advantages of the pass transistor? First one is nothing but ratioless, powerless, lower area. That means ratioless means that we don't have to maintain any pull up and pull down resistance of the corresponding ratio, as well as powerless means that in case of the PMOS transistor, pass transistor, we don't have any static power dissipations, as well as the short circuit path cannot be exceeded, cannot be existing in this case. So that's why it is nothing but a powerless, as well as lower area compared to the remaining CMOS families. This pass transistor logic uses only one gate that can be used to realize the inverter. So that's why it takes a less number of components for the realization of the function. So that's why it takes a very less area. These are the advantages of the pass transistor. Coming to the disadvantages, when the pass transistors are connected in a series fashion, it leads to the delay in the circuit. That is the first problem actually. So let it be see here, this PMOS transistor, any NMOS transistor can be represented as a one resistance as well as a one capacitor. Because of this NMOS transistor is also act as a internally a resistor, right? I think all of you having some basic idea. Junction field effect transistor is also called as a variable resistor. Like this means obviously this field effect transistor is also act as a resistor. So that's why this can be represented in the form of a RC network fashion. If you are observe this one, RC network is also nothing but a low pass filter, right? So if you are connected in the series of networks, it leads to the this is if you are expanding this one. So this is a circuit diagram. So this is a time constant means, let us see the scenario. Wait, those are this is a time constant function for the corresponding expansion, as well as assuming all resistance are equal to that means pass resistance values is equal to R, as well as the capacitances values also equal. The n stage pass transistor network can be estimated using a Elmore's model. We can represent it in the form of a right. So generally time constant tau is equal to RC, right? So based on this one we can expand it, right? So we can get the value of around 0.69 n into n plus 1 by 2 into RC. So if for n is equal to 4, the delay can be represented as a pass transistor delay can be represented as around 6.2 pass transistor. But if you are taking a normally, it takes around 16 RC, right? So that's why by whatever the model you have to chosen for this one also very important. So this is a this represents the buffers are inserted here. The buffers are inserted in between the corresponding every 3 transistors. So this is a one network, and this is a one network, and this is a one network. So every 3 transistor we are inserting the buffers in between the corresponding circuits, right? So let us see. Right, coming to the next one, this is a value for finding the delta. So in contrast to the quadratic dependence on the n in a circuit without buffers, this expression shows a linear dependence on the number n, as an optimal k value can be obtained from the corresponding. So that means the k is a equation that can be used to find the on which stages, after which stages you have to insert the buffers. So with the help of this formula you can calculate the k value. If you are getting k is equal to 3.8 in this case, therefore after every 4 stages you can insert a buffer. So that is a scenario you have to maintain in case of that means the first thing is nothing but first disadvantage is nothing but in case of the pass transistors are connected in chain of fashion, obviously it leads to the long delay. So the long delay can be overcome with the help of a buffers. The buffers can be inserted in between the corresponding pass transistor after every 3 or 4 transistor depending upon the k value. So k value can be estimated with the help of a formula. K is equal to 1.7 into square root of T buffer by R pass into CL. So R value and C value can be chosen from the corresponding expression, and you can calculate. Second thing is nothing but second disadvantage is nothing but as we know that mentioned earlier, the voltage drop across the corresponding pass transistor, that is nothing but V output is equal to VDD minus VTH. As we are going to pass the signal corresponding transistor pass as a chain of a transistor, obviously the last output Q should be very low. So at that time, in order to avoid this one, we needed some additional hardware is required, that is generally called as swing restoration. Swing restoration means that with the help of a PMOS network we can achieve the either highest value or lowest value. So third one is nothing but a pass transistor requires a complementary control input. So pass transistor requires a, so let it be see here, if you are connecting the pass transistor in this fashion, what happens is that, so last one can be treated as a, let it be considered as a 2 volt supply. If you are connected to one a PMOS network, it is a PMOS. It is a, that means if you are running a one inverter network, right, at the time what happens is that, so this 2 volts cannot be sufficiently run this NMOS transistor because of this NMOS transistor may be activated for greater than 2 volt if you are treating a threshold voltage is greater than 2, as well as PMOS is also not sufficiently half of, because of 2 volts is greater than cutoff voltage of the corresponding PMOS transistor. At that time there is some problems will be there. So for that purpose we need to take some swing restoration logic can be provided. With the help of that one we can achieve the corresponding scenario, right? So that is a one more important point. So third point is nothing but, so third one is nothing but, third point is nothing but pass transistor circuit requires a complementary signals. Dual rail logic is usually necessary to provide a complement. That means in case if you want to design a pass transistor family, compulsory we need to provide a charging as well as a discharging path, otherwise output remains maintained same. So for that purpose we need a complementary signals are necessary for this pass transistor family. So these are the different types of pass transistor families, pass transistor logic information. So pass transistor logic families can be designed with the help of NMOS circuit. Coming to the advantages point of view, pass transistor logic families also can be used to implement a multiplexers like 2 by 1 as well as a 4 by 1 concepts, as well as it is also number of advantages like ratioless, power, low power requirement, low power dissipation, as well as a low air area. These are the advantages, right? So coming to the disadvantage, long delay, and second one is nothing but multi threshold volt. That means multi threshold voltage drop means in the each and every stage obviously pass transistor output is going to be decreases. So that's why it is generally called as a multi threshold voltage drop. So third one is nothing but a pass transistor families can be require a complementary outputs. So that's why as a consequence, two mass networks are again required an additional swing restoration for the output buffering circuit. Okay, so this is regarding pass transistor.